right, we are continuing quadratics. We're going to be looking at a lot of different ways that we can solve quadratic equations. The first method we're going to look at today is called the square root method. So I can use this one when I have perfect squares, and these are the steps I follow. I isolate my square on one side. I'm going to take the square root of both sides, remembering to take the plus or the minus, and I'm going to add in a fourth step that I need to get x alone. So sometimes there will be additional steps in order to get that to happen, but let's start with example 1. My perfect square is going to be x squared, so that's what I need to isolate. So I'm going to do that by first dividing both sides by 25. So x squared is 16 over 25, and if I take the square root of both sides, then I know that x is going to be plus or minus 4 over 5. And I'm done. There's my solution. On the second one, I don't immediately have a perfect square, but I do on the left have what is a perfect square trinomial. And if you don't recognize that right away, you can just use your x method to factor. 4 times 1 is 4. My middle term is 4. 2 and 2 multiply to 4 and add to 4. If I divide both of those by my a, I get 1/2 and 1/2. So these are going to match. I'm going to have x plus 1/2 squared, but remember I need to get rid of that fraction, so it's going to be 2x plus 1 squared. So that is my factored trinomial. I now have a perfect square over here, so I can square root both sides, and I get that 2x plus 1 is the square root of 50. Now 50 is not a perfect square, but it does have a factor that is 25 and 2. So this is going to be plus or minus 5 square root of 2. And this is an example of where my step 4 comes in. I need x by itself. So I'm going to have to subtract the 1. So negative 1 plus or minus 5 square root of 2. And then lastly, divide by 2. So x is negative 1 plus or minus 5 square root of 2 over 2. And that is my final answer. I'm going to box it in just to make it super clear. I'll go ahead and do that over here as well. And I'm just going to leave it that way. If it has a radical that can't be simplified further, you can just leave it in your answer. Moving on to number 3, this is my perfect square. I need to get it alone, so I'm going to subtract 12. Now I can take the square root of both sides, and I'm taking the square root of a negative, which means this is going to have an imaginary solution. So I need to simplify this first. So x squared is going to be plus or minus the square root of negative 12. So I need to rewrite this with I first and foremost. So that's going to be the square root of 12i. 12 is not a perfect square, but it does have a factor that is 4 and 3. So the squared is gone now. So x is equal to plus or minus 2 square root of 3i, and the I is outside of your radical. Okay, on number 4, this is my perfect square. So I'm going to add the 36 so that I can get it by itself. Negative 11 plus 36 is 25. So I can square root both sides, and this one has a perfect square, so I'm going to get 2 rational answers this time, meaning I can go all the way through to solve them. So the square root of 25 is plus or minus 5. X is still not alone, so I'm going to subtract 2. So negative 2 plus or minus 5. And then I have to divide by 5. So these are going to be fraction answers, but they are going to be rational because I can express them as a fraction. So I find my first solution by adding. Negative 2 plus 5 is 3. So I'm going to have 3 over 5 for my first solution. Then 2 minus 5 is negative 7. So my other solution is negative 7 over 5. So when you can get a rational answer, you need to take that extra step to solve each of them. Okay, on to number 5. Here is my perfect square, so I'm going to divide by 4 to get it by itself. So 49 over 4. Now I can square root both sides. And I'm going to get that 10 minus 5x equals plus or minus 7 over 2. X is not alone, so I'm going to subtract 10. And then I have to divide by 5, my negative 5, so x is going to be 2 plus or minus 7 over 10. Now again, I can get rational answers for this. I would need a common denominator. If that denominator is 10, then this will be 20 over 10. So 20 over 10 plus 7 over 10 will give me 27 over 10 for my first solution. 20 over 10 minus 7 over 10 gives me 13 over 10 for my second solution. On 6, my perfect square is already by itself, so I can square root both sides, and x is going to be plus or minus, the square root of negative 16 is 4i, and x is already by itself, so I'm done. On 7, my square is by itself, so I'm going to square root both sides, and x minus 6 is going to be, I'm going to have to simplify this. So this is going to be the square root of 80i. 80 is not a perfect square, but it does have a factor that is. 16 times 5 gives me 80. So this is going to be plus or minus 4 square root of 5i minus, excuse that bell. X is not by itself, so the last thing I need to do is add 6 to the other side. And there's my answer to number 7. Lastly, on 8, I don't have a perfect square yet, but if I factor this, it's going to be x minus 1 times x minus 1, which really means x minus 1 squared. So my perfect squares alone, I can square root both sides. The square root of negative 9 we know to be plus or minus 3i. Lastly, to get x alone, just move the 1 to your opposite side. And there's my imaginary solution. And that wraps up our first day of solving quadratics with using our square root method.